All right, so this is going to be factoring video part 2. Last video, if you remember, I showed you how to factor whenever a was equal to 1. Well, today we're going to look at another scenario, okay? What you should notice immediately by looking at this is that our a here is no longer equal to 1. It's anything but 1, okay? Now, here's a nice thing though. B and C doesn't really matter, okay? They're just numbers. B has an X, C doesn't. All right, so that's still pretty standard. I mean, it's still in standard form, just we don't have a as 1 here, which doesn't seem like it should be a big deal, but actually it turns out to be quite a process. All right, I'm not going to lie to you. This is a lengthy process. It's not the easiest thing in the world. It's very important, though. This is one of those difficult things that we're going to use all year, okay? From this point on, once you get from chapter 5 on, you're going to use this over and over again. And I'm not going to stop and reteach you every time. So that's the nice thing about this video. If you need a little, refresher on it, this will give you a nice, easy chance to read things, okay? So, here we go. Now, here's the nice thing. The first step is the exact same, okay? We still take a times c, all right? We still set up our little factoring tree, our little a times c, to give you b, all right? So that hasn't changed. So, in this case, we take 2 times negative 3, because this is a negative 3, to give us negative 6. And we have to find two numbers that add together to give us our b, which is negative 1 in this case. All right. Now, one thing changes here, and I'll write it down, okay? Whenever you put your factors, all right, I'm going to put this. Each factor gets an x, okay? Gets an x. Now, here's what I mean. Normally, we would just do this, okay? We run through our numbers, all right? What times what gives us 6 and adds to give us 1? All right, in case you don't know the numbers, we've got 6 and 1. But no matter how you add those together, making either one, either making this one negative or this one, doesn't matter. You're never going to get negative 1, okay? So let's just cross those out. Now, the only other two numbers, whole numbers that multiply to give us 6 are 2 and 3, all right? Now this one's pretty easy. If you want one to be positive and one to be negative so that they give you a negative 1, all right, it has to be a negative 3, all right? If this isn't a negative 3, then you get a positive 1, which doesn't work, all right? Now here's the thing, and I'll write them in green so they stand out, okay? Each factor, okay, normally we would just do this, okay? If this were last lesson, we would write this. We'd have our parentheses out, and we would put x here, and we'd put plus 2 minus 3, all right? If this were yesterday, we would. But because this a is no longer a 1, all right, the rules change a little bit here. And if I can get this stuff to erase in a timely manner. And there we go. Okay, so now watch. I'm simply going to put an x here with my factors, all right? The x's go with the factors. All right, so that's simply what I mean when I put number 1 there. Each factor gets an x, you put an x there, okay? And the x will stay with them, okay, almost till the end. All right, now, I teach this, I started teaching this last year, 2 years ago, and it sticks with kids, all right? So I hope it's going to work. Here's the thing. First, last. All right, now it sounds kind of weird and doesn't seem to make any sense at first, but here's the thing. You're going to use this verbal cue so that you know where everything goes, okay? In other words, when I say first, I mean that my first term goes first. When I say last, I mean that my last term and its sign go last. So hence the name first, last. Okay, first goes first in the parentheses, last goes last. I know I'm saying this a bunch because I promise you, if you memorize that first, last, you'll be able to solve these all year, okay? I can't tell you how many times people come up to me on tests and all they need is a little kickstart, okay? And they'll look at me and they say, can you give me anything? And all I'll say is, it's first, last. And they'll look at me and they'll go, I got it, okay? So I promise it's going to help. Seems kind of dumb, but I promise it helps in the long run. Okay, now, the way you figure out where your 2x and your negative 3x go, well, again, it kind of depends on the problem. This one's pretty easy though, okay? If you can match the numbers up, always match the numbers up. In other words, I have a 2 for my first term, I have a 2 for a factor, so let's put these together, okay? I have a negative 3 for my factor, or negative 3x, and a negative 3 for my last number, match those together, all right? Now, they won't always be the same numbers. Sometimes they'll be different. So I'll explain what you'll do, I think, in the next problem, okay? Or the next video, one of the two things. So here's what we've done so far. We have done a times c, add to get b. We did the crucial step of adding the x to each of our factors. That's very important, okay? Then we did first, last. Okay? Put the 2x squared and the minus 3 first and last. And then I matched my numbers in where they go, all right? Now here's really what we're doing. I guess I'll just address this now. I am not always going to be matching numbers here, okay? I know this one worked out really well, where there was a 2 and a 2 and a 3 and a 3. Okay, that worked out perfect. But it won't always. Here's what I'm trying to do. I'm trying to put a factor in this spot right here that will be able to have a number in common with whatever my first number is. Okay, in other words, this is a 2. Well, 2 and 2 have something in common. It's the number 2, obviously. Okay, if I were to put a 3 here, 2 and 3 don't have something in common. So it doesn't work there. Okay, so we always want to put numbers that have multiples that are in common. I guess I could put it that way. All right. Now, step 3 here is going to be, let's see, pull out, and we've done this before, pull out a monomial, all right, monomial, can't spell, pull out a monomial, here's the key part, from the first set of parentheses, okay? All right, only from the first set of parentheses for right now. We'll do it again in a second, but I'll show you how this makes it easier, okay? So again, first, last, put your numbers in where the multiples have something in common, okay, like 2 and 2 and 3 and 3, all right? Then we pull out a monomial. In other words, you ask yourself, what does 2x squared and 2x have in common? Now the first thing you should look for is look for a number, okay? Again, what number do both 2 and 2 have in common? The number 2, all right? That's obvious. And there's a second thing you should notice. X squared has 2 x's. This x only has 1. So how many x's do they have in common? They both have 1 x. So we're going to take 1 x out. All right? Now, here we go. Okay. Step 4. The monomial goes in front of the parentheses. Okay, there's my next problem we're going to work on. Front of the parentheses. All right. So your monomial, this 2x that we just took out, right? This thing right here, 2x that we just took out, is going to now go in front of the parentheses. One thing you'll hear me say a lot during this chapter and from this point on is that math is not magic. All right, numbers don't just disappear. When you take a 2x out of something, it doesn't just go away. Okay, it has to go somewhere. So you put it in front of the parentheses, and I'll show you why in a second. All right. Now, when you take 2x out of 2x squared, the 2's cancel out, one of the x's cancel out, leaving you with just an x. And anytime you have something over itself, we should all know by now, is 1. Okay? So, now again, here, you don't have to do this, but you can just watch. Here's why this has to go in front. Because if you don't have this in front, all right, well, let's just say this. If you were to distribute 2x to that x plus 1 again, you'd end right back where you started, okay, 2x squared plus 2x. All right, so again, that's why math isn't magic. You can't just make stuff disappear, all right? You've got to account for everything you divide out. So that's why we put it in front of the parentheses. Now, here's the nice part, okay? And this is something else that you'll remember as we go through the year, because I'm going to say it a bunch, all right? Whatever you get in this set of parentheses right here, right, the x plus 1, you must get the exact same thing in the next one. It's kind of like playing a matching game. You get something in one, you must get the same thing in the other. Okay? So, we have x plus 1 in this one, we must get x plus 1 in the other. Now here's how we do this. Pretty much we repeat the whole process again. We say, all right, well, what monomial can I take out of negative 3x and negative 3? All right? The key is it has to give us x plus 1. Okay? If it doesn't give us x plus 1, we're wasting our time. So, we ask ourselves, well, negative 3x divided by what gives us x? Okay, and the answer is negative 3. And if I divide out of 1, I got to do the same out of the other. And it works perfectly here because negative 3 over negative 3 gives us 1. Now, just like I've said, math isn't magic. So we bring the number down and we put it right in front of the parentheses. Okay? All right. Now, this next step confuses a lot of people. I don't know why, but it always seems to. Okay? So, here's what you do. You bring down, I'll write a different color, one of the common terms, okay, this right here, the x plus 1, and you put it in parentheses, just 1, all right? Now we're doing this because both 2x and negative 3 are being multiplied times the same thing. So since they have a common thing that they're multiplied times, we can just take that out of the whole equation, which is what we're doing. We're taking this x plus 1 out of the 2x and the minus 3 and putting it by itself. Now when you do that, you're basically forcing these two things that are left over here, the 2x and the minus 3, to be grouped together. So we get 2x minus 3 times x plus 1. All right? Now, if you were to FOIL this, I'm not going to do that, but if you were to FOIL this, you would end up right back where we left off at 2x squared minus x minus 3, way back up here at the top. Okay? So, all right, so to finish this video, I'm going to work another problem in another video, though, just so you can have one. But I want to re-go over this one more time. All right? Notice, I did this because a here was equal to 2. A was not equal to 1. So we followed the same procedure as last time. We took a times c, add to get b. All right? Now the only difference here is because a is not 1, we had to put these x's here on our 2 and our negative 3. Okay? So once you get past there, you can begin the setup process. All right? And we do first, last, last. First, last, last. Okay? Then we plug our numbers and their sign in. Okay? Well, we plug it in wherever we can pull something out. Again, you could see, again, this has all been done, so let me just change this real quick. If I had made this the 3, all right, this wouldn't have worked, because you can't divide something out of this 2x squared and that 3x. It doesn't work. All right, so you always put numbers together that have multiples in common, so you can divide something out. Then, I know you can't really tell because we already did it in order, but you deal with just the first parentheses, okay? You take something out in common, in this case the 2x, and you put it right in front of the parentheses, okay? And in the parentheses you write down what's left when you take it out. So 2x squared over 2x is x, 2x over 2x is 1, right? Remember the key is, if this is x plus 1, this must also be x plus 1. Okay, we don't even have to do anything, we can just rewrite it there. And then we just kind of fill in the blank. We say, what can we take out of the second parentheses to give us x plus 1? The answer was minus 3. All right, and then as you can see, we combine our outside terms to give us this answer, and we bring one of our common terms down to give us that. All right, just one of the common terms. You don't ever bring both down, okay? Just one of the common terms. So, all right, so there you go. Now I'm going to make another video. It's going to be called Factoring Part 3, and we're going to come back and I'm going to solve this problem again. Okay, it'll be a much quicker video, I promise. All right, thanks for watching.